Today, we'll be presenting the phase D of Capstone 2 of the Baja project. The members of this group are Gabriel J. Cono Ortiz, Antonio Peña, José Aborre Burgos. Here, we present the authorization to continue with the phase D. We'll be discussing the following topics, which are the system validation, project plan, and system budget. For the validation of the system, we must first validate our objective of phase A that we established as the main objective for the Baja. Design and build a mini Baja which is competitive and meets the standards to get the highest score and win the SAE competition. The maximum points to be able to win the competition are 2,600 points. Now, we will continue with the verification of the system according to the MOPs of phase A. In the table, it shows in which phase each MOP of each subsystem was completed, the type of verification or validation. But in this case, it was only verified already that we do not have tools to validate these MOPs and because of the pandemic. Finally, whether each MOP complied or not. So, to validate our first MOP, we need it to the certification are no exceed from 16 inches in wide. The necessary tool to validate this MOP are a computer and the SolidWorks software. And the steps to follow are enter to the SolidWorks program and check dimension with Smart Dimension tool. To validate our second MOP, we need to safety preparation need to support a fall from a height of 6 feet. The necessary tools to validate this MOP are a computer and the SolidWorks program software. And the steps to follow are enter to SolidWorks software, create a new study, select a material, fix advisor joints. Second, select the joints and apply the force in the direction of impact and run the study.
Hello, my name is Antonio Peña and I continue the system verification for the chassis. MOP to verify. Secondary member minimum wall thickness of 0.035 inches and minimum outside diameter 1 inches. Safety precaution not exceed from 0.035 and 1 inches. Tools, component, computer, and SolidWorks software. Procedure steps to enter to SolidWorks program. Check out the dimension with the Smart Dimension tool. Okay. System verification. With trained members may not lower than 40 inches. Safety precaution exceed from 40 inches. Tools, computer, and SolidWorks software. Procedural steps. Enter the SolidWorks program, check out the dimension with the Smart Dimension tools. Continue. Pen members may not have a bend greater than 30 degrees. Safety precaution exceeds from 30 degrees. Computer tools, computer and SolidWorks software. Procedure. Entering the SolidWorks program, check the dimension with the Smart Dimension tool. Frame must weigh less than 100 20 pounds. Safety prevention, no application, tools, computer and SolidWorks. Procedure steps. Enter to the SolidWorks software, apply the material ANSYS 4130 to the frame, select the mass property. In this case, the mass is 63.76 pounds. People between 5 feet and 6 and 2 inches and 6 feet and 4 inches tall and the 130 and to 250 pounds in weight. Safety precaution not apply. Tools, computer and SolidWorks. Procedure steps. Enter in the SolidWorks system for height checkout. Check the dimension with Smart Dimension tool. For weight, create the new study. Select the material. Fix a feature joint. Select the joints and apply the weight in the direction of impact from the study. In the left is the force applied in the chassis and complete. For the powertrain system verification, powertrain wires must be ANSYS 1010 or 61 T6 aluminum. Safety precaution not apply. Tools, computer and SolidWorks. Procedure steps. Enter in the SolidWorks software, apply the material ANSYS 1010 to the sprocket box case. System verification for the powertrain drive, the shaft shall be contained from powered via two drive shaft hooks widening 51 millimeters or 2 inches of the 1/3 length point and the 2/3 3 length point. Safety prevention apply. Tools, computer, and SolidWorks software. Procedure steps. Enter in SolidWorks software. Apply the material and system to the shaft. Apply the diameter for the shaft 2 inches. The drive shaft hooks shall be minimum of 25.4 millimeter in 1 inches wide, meaning the same material requirements. Safety precaution not apply. Tools, computer, and SolidWorks software. Procedure steps. Enter in the SolidWorks, apply the material and system to the shaft. Apply the diameter shaft 1 inches. The powertrain system must be able to operate with a total weight of 1,000 pounds maximum. Safety prevention no applicable. Tools, calculator. Procedure step. Estimate the maximum mass that the powertrain can support. In this way, we identify if the touch obtained can be operated with sufficient power possible for the handling test. According to the result, the powertrain system can be operated up 725 pounds. In the right, the maximum capacity, the mass of the car estimate is 1725 pounds estimate. This is the rolling friction and sand. This is 0.28 for her kilometer for hiking, and this is the formula m per cos 30 rate degree. In this case, the result is 380.89 pounds per feet. Maximum torque strength is 386.02 pounds per feet.
Good afternoon. My name is Jose Borges, and today I will be presenting to you my system verification presentation for the brake subsystem. The first MOP to be verified is the primary hydraulic braking system shall act on all four wheels with a single foot pedal. We have no safety precautions. With the tools, we have a computer and the SolidWorks software, and the procedure is opening the SolidWorks software, ensure the 1/4 of an inch brake lines are mated to the master cylinder fitting holes, and ensure the master cylinder are mated to the pedal. We can observe these two procedures are met in the picture below. Another MOP to be verified will be that the master cylinder should the correct dimension will be 5/8 of an inch and shall be operated directly by the paddle. We have no safety precautions for this verification. The tools will be the computer and SolidWorks software. The procedure steps will be open SolidWorks software and apply the Smart Dimension feature to the master cylinder piston diameter, and it will be 0.625 inches. That's equal to 5/8 of an inch. We can observe the pictures below with the right dimension. Another MOP to be verified will be the brake system 7.5-inch disc or rotor must be able to lock all wheels in rough competition conditions. We have no safety precautions for this MOP. The tools will be computer and SolidWorks software too. The procedure steps will be open SolidWorks software, apply the material stainless steel 316 for the disc, the smart dimension feature to the outside diameter of the rotor, and the dimension will be 7.5 inches. The other MOP will be the components material shall be steel or aluminum and shall withstand 450 pounds or 2,000 newtons pedal force. We have no safety precautions, and the tools will be the computer and SolidWorks software. The procedure is open SolidWorks software, and we will run a stress and displacement study simulation to ensure the pedal withstands the 550 pounds force. Here in the picture, we can observe the simulation for the stress test and the displacement study. The 16th MOP to be verified will be with the brake lines. The dimension will be 1/4 of an inch and shall be placed securely and shall not interfere with suspension or steering. We have no safety precautions for this MOP, and the tools will be computer and SolidWorks software. The procedure should be open SolidWorks software, select the smart dimension and apply it to the brake lines part, and we have to ensure the brake lines is configured flexible. The 17th MOP will be lines material should withstand the pressure created by a paddle and must be compatible with the brake fluid used. The safety precautions, we don't have safety precautions for this MOP. The tools will be SolidWorks software and a computer. The procedure will be open SolidWorks software, and we have to make sure or verify that the material for the flexible configuration on the lines will be stainless steel 316. On the right, we have an image with all the calculations to prove that the lines on this material will withstand the pressure applied by the brake fluid. Here we have the project planning from the next phase, that will be phase F, and we will be presenting on the first week of May, on May 5. Finally, we have the system budget here. That will be the distribution and the prices of every subsystem for the whole system. First, we have the chassis subsystem. We have a 29% of the total budget with $4,398. The powertrain subsystem have a 22% of the final budget with $3,250. The brake subsystem have 8%, it will be $1,252.05. The suspension will be 16% with $2,400. And miscellaneous, we have 25% of the final budget with $3,700. Well, with the final budget will be 15,000 with 5 cents. And we on the right side we will have a pie chart with the distribution of each subsystem. That's all for today. Thanks for your attention.